Hey guys, so this is LULU-MINING. So from the previous video we forgot to indicate whether it's tension or compression. So this one was supposed to be tension, yeah, because of it answer came out to be negative. Okay, so you just have to indicate whether your answer will be tension or compression. Then these two were in compression. Okay, answer gave us a negative answer, and there was a negative answer. So you have to indicate. Okay, so take note of that. So today we are continuing with the method of method of section, sorry. Yeah, so today we'll look at this question. Okay, so the first thing which I did here, or the first thing you could like to do, is to understand the question. So the question states, determine the forces in the members of EF, CF and BC, and state if tension or compression. So you have to state whether it's tension or compression. Okay, so the diagram, whatever is inlaid, was known to you there. So what I did, because I want to make the video as short as possible, yeah. So what I did, I had to board the members which they are talking about. So we have EF, okay, which has been mentioned there. Then we also have CF is here. Then we also have BC. So after you board them like that, then you cut over the member, and the unknown members should not exceed 3. That's what we said from the previous steps which we talked about. Okay, and I said on the next video I'll talk about this step 3, where we said if required, determine necessary, okay, supportive reactions by drawing the free body diagram of the entire truss. Then you apply the equation of equilibrium. Okay, so though it will not be very much applicable here, but I just want to show you. Yeah, so by doing that, you have to understand the concept that we have what's called a pin and a roller. So you have to know the force which a pin is supposed to have and what the force which a roller is supposed to have. Okay, so for a pin, it will have two forces: the one which is preventing from going in, and the one which will prevent it from sliding in. So to have that force opposing that way and that force opposing that way, so you have to show them like that. Then for a roller, it won't have one force because it can move in that direction, so it won't have one force which is preventing from going in that direction. So you have to understand this, okay, because in some trusses you'll be given an external force. Maybe if there was an external force here, okay, if there was an external force here which is unknown, okay, you can use this principle, step 3, by finding the unknown force, okay, by applying whatever I'm talking about here. So what we usually do, we are going to say, allow me to use a red pen. So we are going to say there is a force here which is which is A in the Y. Pen, what's wrong with this pen? Okay, so which is A in the Y, then you are going to have a force there, okay, which will be A in the X. Okay, so we are going to have those forces. Then we also have a force which will be in that direction, which will be B in the Y. Okay, so we are going to have that. So from here we are saying you have to apply the equations of equilibrium if required. Okay, so here I'll say summation of the forces or summation of the moments will be equal to 0. Okay, so I'm going to take the moment at point A. Okay, and why point A? Because we have to take a point where most of the forces are passing through, or a pivot where most of the forces are passing through. So if you see on point A we have that force and that force, so that's why I've picked A. So if I pick A, if I say moments, so what you have to understand by moment, we said moment is just force times moment is equal to force multiplied by the distance. Okay, so that's moment. So then you have to know that clockwise and clockwise will be positive, then clockwise will be negative. Okay. Okay, so we have this which is going to the anti-clockwise direction, that one anti-clockwise. Then what else do we have? So when I put my pivot here, these we are going to exclude them. So we have this one. So I'll say B in the Y. Okay, it's positive, it's anti-clockwise. Then minus. Okay, so B in the Y, open. Open. Then we multiply by the distance. So from here to here we have 1.5. Okay, then we'll move to this one, which is a negative anti-clockwise. So we say minus, which is 8, open, times its distance, which is 2. Okay, negative 4. Okay, times the distance. So the distance we are going to avoid is 4. Okay, then equals 0. Okay, equals 0. Then we'll compute this. So let's compute that. So we're going to have that. Then the first 2 will go the other side, so that find B in the Y. So if I divide by 1.5, even here by 1.5, I'll cancel, and I'll have BY will be equal to, okay, so BY is giving me 21.333. So I'll write to 2 decimal places 21.33, which is in kilo newton. So you're going to have that answer. Okay, and since it's positive, you can show that it's what, a tension force. Okay, so I just wanted to show you this, though in the question we are about to solve, this will not be applicable. So if you have external forces here which are not known, after finding this, you can do the summation of the forces also in the x and in the y to find some of the external forces which will be there. Yeah, so we have just found the supportive force, which is BY, which was this one. But all in all, I just wanted to show you that. But let's go back to our question.